Welcome to video lecture series on subject serving. Today we learn the topic unit number 6 modern serving techniques, in that introduction of modern instrument. So, as per the syllabus we know the different instrument, that is first is the total station, second is the electronic distance measurement, third is the remote sensing, fourth is the geographical information system, fifth global position system, that is GPS. So, one by one we learn about that instrument. First, in case of the total station, we see the fundamental parameter and its uses. In electronic distance measurements, we see the types, principle and measurements. Remote sensing introduction, history, types and application in civil engineering. Geographical system introduction to the basic component and its application of GIS in civil engineering. Then global position system introduction, component, application of GPS in civil engineering. So, first we see the EDM, that is nothing but the electronic distance measurement. So, this measure instrument is used to measure the length between the 2 points using electromagnetic waves. This is very important. When you measure the distance between, as we know that there are different methods to measure the instrument, to measure the length, such as we have to measure the length by using the manually, by chain, tape. These are the linear measurement, but by using the electronic distance measurement, these techniques we have to get the accurate result, and we have to get the accurate distance between the 2 points. So, EDM is commonly carried out with the digital instrument called theodolite. EDM instruments are highly reliable and convenient pieces of observing instrument and can be used to measure the distance up to the 100 kilometers. That is nothing but we have to measure the distance up to the 100 kilometers. Each pieces of EDM equipment available at engineer supply provide dependability, accurate distance measurement displayed on easy to the read and digital screen. Device known as total station share the similarities with the theodolites and can be used to measure the distance as well as angles. So, EDM is same as it is theodolites, but that is one of the application. You have to measure the distance between the two objects. Okay. So, you can see here the that EDMs. So, here the touch screen, or you have to see the screen, this instrument, over that you have to measure the distance. You can clearly visible just bisect your object, and you are using by this screen pad you can find out the distance between the two objects. The method of direct distance measurement cannot be implemented in difficult terrain when the large amount of inconsistency in the terrains or large obstruction exist. This method is avoided. So, as we know that, so in case of the difficult terrains where the undulated, the our conventional method, that is the you have to measure the length and by using the tape, it is a difficulty. So, in this, by using the electronic distance measurement, you have to get the directly distance as an alternative to optical distance measurement was developed. Still, you have to some advantages. It is limited to 15 to 150 meters with the accuracy of 1 in 1000 and to the 1 in 10,000. Above all, we have EDM with an accuracy, that is nothing but the we have the instrument has a larger accuracy. Okay. Electronic distance measurement is a general in terms of use in method for measurement distance by electronics means. In this method, the instruments are used to measure the distance that rely on propagation, reflection and reception of electromagnetic wave like radio, visible light or infrared waves. We can see how it can be measures the distance between the two objects, that you remember that there are radios, visible lights and infrareds, and it can be transferred to the receiver can be received, and you have to get the distance between them. Okay. Electronic distance measurements is a way of determining the length between the 2 points by looking phase changes that occurs as electronics energy waves, which travel from one end of a line to the other. But when the large variation occurs in the terrain, or when there are great deals of the abstraction, this method isn't an effective. So, this method three types of the instrument that is use of electronic distance measurement, which are based on their methods to be used. Microwave instrument are also called as tellurimeters. These instrument was microwaves and they have been around since 1950s. Infrared wave instrument use a prism reflector that pick up amplitudes modulated infrared waves at the end of the line. Visible light wavelength use modulated light waves to measure up to a specific range. So, electronic distance measurement is a way determining the length. Okay. So, first we see the microwave instrument. These instruments make a microwave. Such instrument were the invented as early as 1950s in South Africa, named as tellurimeters. The instrument need only 12 to 24 volt batteries. Hence, they are light and highly portable. Tellurimeter can be used in a day as well as in a night. The range of this instrument up to the 100 km. It consists of the two identical unit. One unit is used as a master unit and other as a remote unit. Just by pressing a button, a master unit, you can convert it into a remote unit and a remote unit into a master unit. And then here the skill person is required. Okay. Then infrared wave instrument. These instrument amplitude modulated infrared waves are used. Prism reflector are used at the end of a line to measure. These instruments are light and economical and can be mounted on satellite. With these instrument accuracy up to the plus or minus 10 mm. The range of these instruments up to the 3 kilometers. The most we have given the names as a civil engineer work, that is a Distromat D1 1000 and Distromat D1 55. So, this instrument is given according to their trade name. Okay. Visible light instrument. These instruments rely on the propagation of modulated light waves. These types of instrument was first developed in Sweden and was named as a geodimeters. During night, its range up to the 2.5 km, while in the day its range is up to the 3 kilometers. Accuracy of this instrument 0.5 mm to 0.5 mm per kilometer distance. Okay, this is used for the for civil engineer. Then principle of the EDM is that the transmitter at the master station send the modulated continuous carrier wave to a receiver at a remote station from which it is written. The EDM measure the slope distance between the transmitter and the receiver. It can done by the modulating continuous carrier wave at a different frequency and then measuring the phase difference at the master station between the outgoing and incoming signal. So, you can see here operation, it is essential know the fundamental principle behind EDMs to work when the electromagnetic wave propagate through the atmospheric based on the equation where V is the velocity of the electromagnetic wave in meters per second, F is the modulated frequency in hertz and lambda is the wavelength in meters. Mainly the waves that propagated can be represented like sine waves as shown in figures. Okay. Then let AB is the survey line is to be measured having the length of the D. The EDM equipment is placed at between A and B. Transmitter is placed at A and the receiver at the B. The transmitter lets propagation of electromagnetic waves towards the B. A timer is also placed at the instant of the transmission of the wave. A is the timer and B start and stop at the instant of reception of the incoming wave up to the B. This able use to know the transmit times of the wave from A to B. From the from the transit time and the known velocity, the distance can be easily measured. Now, to solve the problem arise to difficulty in starting timer at B, a reflector can be replaced as shown in below instead of the receiver in the B. So, here you can see here directly this is a EDM This is a receiver reflector. The electromagnetic waves is reflected towards the receiver. It can be received and it can be again resent to the that instrument. Okay, that is again to the EDM instrument. So here EDM transmit the electromagnetic wave toward the reflector. Reflector again transmit toward the receiver of the your instrument. So you have to get the distance between the A and B. Okay. Then use measurement of the baseline in triangulation survey, measurement in the length of the survey of traverse survey, measuring the vertical or sloping distance between the any points to obtain missing line measurement to establish triangulation ground station. Okay. Thank you for listening. If you have any difficulty, we have to discuss in our discussion session. Thank you for watching this video. Thank you.